Here I'm running a Xonar Essence STX with a modified Softrock that takes -8 dBm as the maximum input level before the op-amps in the Softrock saturates. And here's what I see in Linrad. And it's better than normal. I mean, glitches are not so frequent. Looking here, I press A. We can see that the amplitude margin is 2.5 dB, and that's very reasonable. Now, the glitches come because I have these windows open, so I close them. I need them to get the card running properly, and they have to be used after every reboot. I have calibrated the S meter to show -8 dBm, and then I can switch off the signal generator and get a noise floor of about -115 dBm. I'm now using this crystal oscillator, which is very good, and I have set the attenuator to make it produce -8 dBm. 8.1, well. And the frequency is not at the optimum place and not at the worst place in the baseband spectrum. The Osus Xonar has an ugly noise floor. This would probably be fairly easy to fix by suitable decoupling capacitors, but that is not something that I'm going to spend my time on. I'm studying reciprocal mixing in this video. Now it's the Asus Xonar. I have placed a strong signal not at the usual position here somewhere, but at the point where the noise floor is fairly low. And now I will change the frequency by 20 kilohertz while looking at the noise floor. 5, 10, 15, 20. And as you can see on the S meter, the noise floor didn't change much. I can remove the strong signal to see the effect of reciprocal mixing at this frequency separation. Now the strong signal is gone, and the difference is maybe 1 dB, and that's not because of the sound card, that's because of the Softrock, the SI570. So the number I read out to put in the database of sound cards is from here to here, -118.7. And I step the frequency upwards to look for possible unpleasant things that could be present. I'm now at 14.24. I don't remember the start frequency, but maybe about 100 kilohertz. Anyway, it's clear this sound card does not suffer from any reciprocal mixing problems. I have now put a Sound Blaster live on the PCI bus, and I run the auto update from Creative. And it finds this product SB live, and I click check update, and it goes fairly quickly. Your system already has the latest versions installed. That should be good, but it isn't. I check the device manager, the multimedia audio controller here, properties. The drivers for this device are not installed. And the reason is something with the security checking, something that I don't understand, but it doesn't matter what I do, I cannot get the drive routines back. I had them installed here before, but now no longer. Probably I would have to run the installers and then manually remove various files to make the system believe I hadn't have this card installed before. Now, this is Microsoft Windows, and I'm not interested in the software things. I'm just going to look for the reciprocal mixing of the hardware, so I leave Windows and go for Linux. This is Ubuntu 12.04. It's a long time support version of Ubuntu. And I'm using capture and line input. Well, I don't need this one. There is a special thing with some of these Sound Blaster cards or their drive routines. Look at the balance between signal and mirror image. Here is the signal and here is the mirror. And I change the frequency to move them a little bit further away from the center. And at this distance you can see that the signal and the mirror are nearly the same. This means there is a sample shift, and I have to correct for that. This is the driver I'm using, and the time shift is 0, and I have to change that. And I do that by pressing A, and A for sound card, and no port audio, and device number 5 was what I was using. And speed, of course, 48 kilohertz, and then 2, and I try to put 1 here. The other alternative that is likely is -1, and then 3 for the SI570, and I don't care about the output, so I put Z there, and XX and D. And then you can see it was the right sign. The mirror image suppression at this frequency separation is reasonably good. I can run the calibration routine to make it a little bit better. The amplitude margin is 3 dB, a little bit more. But if I go on the ALSA mixer and step the level 1 step upwards, that's with the arrow K, it increases from 7 to 13, whatever unit that might be, and reduces the amplitude margin to 1.6 dB, but something goes non-linear. You can see all the lines here or you can see them in the spectrum also. So this is too much. It would be nice to put this somewhere in between, but I cannot do that. I don't know how to. So I have to run like this and accept the margin. I press Z. Oops. So this is some odd thing. I don't know how that happens, but like this. Now I have 7 in both channels, and I have 3 dB as the amplitude margin. And this is where I do the measurements. Signal source, this good crystal oscillator, attenuated to give -8 dBm on the input of this modified Softrock. And the S-meter is calibrated to show -8 dBm. Well, I run it a little bit faster. -8 dBm. Bandwidth 1 kilohertz. And I'm looking for reciprocal mixing, so I step the frequency in steps of 5 kilohertz. 5, 10, 15, 20, and the frequency separation seems to have no effect. The noise floor is at the same level, and I check that level. Let's see what we get from here to here. Once more, from here to here. This is a bug that I have not yet corrected, but I will do someday. The level is -109.4 dBm. I can switch off the strong signal like that, and it's obvious that the noise floor does not change. This means what I see is not reciprocal mixing. The contribution from that is very small. So this is just the noise floor of the sound card. And as it happens, the Windows driver seems to be a little bit better, because when evaluating dynamic range, it became a little bit bigger. That was dynamic range without any strong signal. But as you can see now, the presence of the strong signal does not affect the noise floor. So this is always the problem with hardware, how to get the correct drive routine. These Sound Blaster cards, creative cards, typically have several gain controls after each other, and it's important to set the right one to avoid saturation in front of the ADC, like we can have in this driver. But getting a driver working in Windows again doesn't mean anything. We just know that reciprocal mixing is not present up to 20 kilohertz, and I will step the frequency upwards to see if there is something on higher frequencies, higher frequency separations, but that is very unlikely. So going upwards, this is now 100 kilohertz, and I don't see anything. So this card, a little bit high noise floor, not the proper driver, but otherwise this is surprisingly good. Now I made a mistake. What I called previously Sound Blaster Live was actually the Sound Blaster Live Digital, the card for Dell computers. I had swapped cards while trying to get drivers working and forgot about that. So here is the SB Live value, and you can see the information about the chip is different. This is Cirrus Logic. The other one was what was it? I don't remember, but it was some other. It was Sigmatel on the SB Live Digital. So this one looks much better. Look at the noise floor. It's more flat and seems to be lower. And the amplitude margin, I have to press A for that, it's very low. It's 0.7 dB. And I can set the capture on 13 without any nonlinearity problems. And the signal is -8 dBm, and I have calibrated for that, as you can see, hopefully. And I will step the frequency upwards in steps of 5 kilohertz. 5, 10, 15, 20, and I will look for the noise floor at 20 kilohertz separation. And this starts to be annoying. Anyway, the noise floor is -114.5. I switch off the strong signal, like that. And the noise floor goes down just a little bit. So there is some reciprocal mixing. Probably it is from the Softrock itself and not from the sound card, but I'm not sure, and I don't want to spend time investigating that because it's such a small effect. -114.7, that's 0.2 dB of reciprocal mixing. That is something we neglect. I will step upwards in frequency to see whether there are some oddities. Oh, I have to do that with the strong signal present, of course. So I put it back and go down again. And now, well, I can clear the screen a little bit. And I go upwards in frequency with the strong signal present. And I look at the main spectrum at the same time to see if there are any noise humps or something, and I see nothing of that. Performance of this 48 kHz 16-bit card is clearly better than several of the 96 kHz 24-bit cards when I measure the dynamic range with the strong signal present. So it is not a bad choice, but this is the Sound Blaster Live with the Cirrus Logic chip. It is not the Live Digital, because that has a not so good chip from Sigmatel. This is the external 24-bit Sound Blaster Live. The ALSA mixer only has one volume control, labeled the microphone, and I can change it, but doing so does not affect the spectrum I see, and the amplitude margin is 5 dB. So this card is not being used properly under Linux. Under Windows 7 with port audio, line in, mic in, 24-bit external, up to 96 kHz, 4 bytes. So that looks promising. But this is what happens when I try to use it. So I have to use the sound properties of Windows and make sure that this is set correctly. Yes. And as I have learned from other drivers, it is a good idea to set everything to the same speed. Everything that can be set to the same speed. Also the output of all the devices present on the system. That did not help, so I tried this driver instead. Number 41, that's WAS API, 96 kHz only. This works. I have to set the gain to 89. Then the amplitude margin is 0.2 dB, 0.3 dB, and the spectrum looks nice. So I will change the frequency in steps of 5 kHz. 5, 10, 15, 20. And you can see here nothing happens of particular interest. The noise floor is, well, from here to here. This starts to be a little bit frustrating, but I want to make this sound card thing ready before going to find what is the bug in Linrad causing this. The noise floor is at minus 114.4. And that is with a strong signal present, and I switch off it. And reciprocal mixing is very small. The result is the same as what I saw with the SB Live, the 16-bit card. And the explanation is obvious when I look in the oscilloscope mode. The card is giving 16 bits. But this is what ALSA is reporting. Sorry, this is what port audio is reporting. It should be number of input bytes 4, so I should have all the 24 bytes, the 24 bits. But the usual thing is, don't trust drive routines, you have to test them. Now I have selected the MME drivers without port audio, and they provide 24-bit, as you can see here on the oscilloscope tracing. Signal levels have not changed. It is still minus 8 dBm, and the S-meter is calibrated the same, and the volume control is the same, and the amplitude margin also. So again I step in steps of 5 kHz. 5, 10, 15, 20, and I look for the noise floor, which is here, minus 115.9. I switch off the strong signal, like that, and here we can see clearly reciprocal mixing now. So I go back with the signal and step further upwards in frequency. And here things start to look not so pleasant anymore. There are many little spurs and several not so small spurs. It seems I have to reduce the signal level. I back off by 1 dB, 2 dB, 3 dB. So it's not a saturation problem, it is a problem with poor digital filtering in the sound card. That's not so nice. Let's continue. And you can see the noise level here is pretty high and the noise floor is going up. So this card suffers badly from reciprocal mixing, and this seems to be the worst point, approximately here, 270. This is, oops, very odd. Something dramatic happens when the signal comes a little bit further away. Anyway, here the noise floor is minus 105, and that will be the value I report in the chart over sound cards, because it is likely that we have strong signals 100 kilohertz away from the signal of interest when using the Softrock, and those are not much attenuated by the op-amp filters, but they are attenuated in this box, as is normal for a Softrock. So this is a little bit surprising. It's also surprising that the difference between 16 and 24 bit is only 1.5 dB. I continue now stepping 5 kilohertz, looking at the main spectrum and waterfall. So the current frequency is 14.265, and I go upwards. Here the noise goes down, but there are many little spurs. And here is something ugly coming up, which moves in an unpredictable way. And here there is another peak of ugliness. And I'm stepping only 5 kilohertz each time. Now the noise floor is very high again, at 14,325. So this card is going to cause problems from stations far away from the region of interest. Sound cards are typically sampling at some overtone, maybe 64th overtone at say 6 something megahertz, and then they apply digital filters and decimation. And there is something wrong with the digital filter in this particular box. This one, I think. Or maybe there is some other explanation that I don't understand.